Let's see if that works. There we go. Guys, let me know in the chat window if at some point you actually start hearing the sound, okay? And then we can kind of move forward. Hopefully the sound starts working at some point. That would be ideal. Let me know if it doesn't. Now it's working. Oh, okay. Sorry, I forgot to put sound in. Okay, so I'm going to start trying to go over some of the stuff you guys are asking about. So it looks like we want to first do changing standard form to vertex form. Let me give that a shot and we'll see how it goes. Okay. So standard to vertex form, I'm going to try just kind of a hard enough problem so, we're at least doing something that is fairly reasonable. I don't want to do too easy, but I don't want to do crazy hard either. You shouldn't expect to see too much crazy hard stuff here anyway. So I'm going to do y equals 2x squared plus 8x, let's go with plus, I don't know, 7 or so, and we'll just see what we got. So this is what I'm going to do. I'm going to do this one, okay? Remember, when you're converting into vertex form, you're basically trying to get it to look like this, right? That's what you're trying to get it to look like at some point. So you, it could be a plus inside that parentheses too, but the biggest thing is you're trying to factor out, your greatest common factor there, and then you're trying to get a perfect square trinomial, and then whatever that number, k is at the end, that doesn't really matter too much. That one's just going to kind of tag along for the ride, so to speak. So what you're going to do is you are going to try and take out a GCF from just the first two. And actually, I shouldn't even say GCF. That's incorrect. Whatever that first number is, you are going to definitely take it out. Okay? So I took out the 2, made that x squared plus 4x. I didn't take it out from the third one because, again, that number is just going to become k in the end. Okay? And I think it's easier to create a perfect square trinomial without that one getting into play. So then I figure out what number makes a perfect square trinomial. So to do that, I'm basically going to take that 4, where am I pointing? There, and I'm going to divide it by 2 and square it. So 4 divided by 2 is 2, 2 squared is 4. So I'm going to add 4 to complete the square. Luckily, I have a handy second color here so you can kind of see that. Now, to balance that out, the key is, normally I would just subtract 4, but because of that 2 that's outside parentheses, since I added that 4 in those parentheses, it was really like I added an 8. So I'm actually going to subtract an 8 to cancel it out. So it's really just like I added 0, because I added 2 times 4 to that whole parentheses mess, and then I subtract an 8 to balance it out. And then after that, all that's really left to do is factor. So it's y equals 2 times x plus 2 quantities squared minus 1. So that's what we should have. Okay? Okay. So that's a quick go over that. And the big keys there are, make sure that whatever number this is, you take that number out and only from the first 2. Okay? Other questions? Let's see. So, okay, so we're talking, Caroline Harkless has asked two related questions, and that's good. So she asked, how do you know if there are no x-intercepts, and also asked, how um, do you find the second intercept in vertex form? Let's actually talk about how we know if there's no x-intercepts. Um, Actually, this should be really easy to do in all three different forms, as long as you figure out the vertex first. So, um, obviously, if it's an intercept form, you have two x-intercepts. Otherwise, you're not going to use intercept form. So for the other two, though, it's actually pretty easy to tell. So what you're basically going to do is, whether it's in standard form or vertex form, figure out the vertex first, okay? And then if that vertex is either in the first quadrant or second quadrant, so kind of where I put those two dots, then you just have to say, okay, if my graph opens up, then that means it's going to look, I totally missed my vertex. That's really awesome. Um, so if the graph opens up and it's in one of those first two quadrants, there can't be an x-intercept. Okay, same thing if it's in the lower two quadrants, if that's where your vertex is and it opens down, there's no x-intercepts. So now the question is, how do you know if it opens up or down? Well, if it's in standard form, it's A. So if it's in standard form, if my A is positive, then it's going to be the U shape. It's going to open up. And if it's negative, so less than 0, it's going to open down. Okay, so basically, if I figure out my vertex and it's up here, and A is positive, I know there's no x-intercepts. If I find my vertex and it's below the x-axis somewhere, then I know for sure that it opens, and it opens down, then I know for sure there's no x-intercepts. Guess what? It actually works the same way in vertex form too. So again, it's still that letter A. So vertex form, it's probably really easy to tell if you have no x-intercepts or not, because you'll be able to pick the vertex out right away from here, and then you can just use A to figure out, well, is it going to open in the right direction for me to have x-intercepts? So that's how you figure out if you have any. So I would suggest pretty much always figure out your vertex and what direction that parabola is going to move first, because then you know if you need to even bother finding x-intercepts or not. As for how you find the second one in vertex form, let's just do a quick example of finding x-intercepts in vertex form, because that'll probably help. Let me write up something. Let's go with that. Yeah. So let's say we had something, oops, I'm going to make that a plus 16, otherwise this is going to work out really badly. There we go. Okay, so let's say I had that. Again, the way you find x-intercepts here is you basically isolate the parentheses squared part. You're just going to try to get that by itself after you plug in 0 for y, excuse me. So we're going to plug in 0 for y and then subtract 16 from both sides, and then divide both sides by -2, and eventually we'll get to, oh, I chose a terrible example because I'm a genius, and eventually we'll get to 8 equals x minus 2 quantity squared, so we'll get to this. Okay, so I set y equal to 0, I subtract 16, I divide by -2, and I get 8 equals x minus 2 quantity squared. The key is, when you take this square root, you're gonna get x minus 2 equals whatever the square root of 8 is, like 2.8 or something. And what that means is, though, because you took the square root, remember when we did this originally, we put absolute values there? While you don't necessarily have to put absolute values there, what it does mean is that you need to set it equal to the positive version of that number, and the negative version of that number, okay? So I'm having trouble loading a calculator right now, so I'm just going to approximate this as about, I'm going to guess 2.9 is about what the square root of 8 is. We'll just hope I'm about right. So what you would do is you would set up two equations, and you would do x minus 2 equals 2.9 and x minus 2 equals negative 2.9. And you would just solve both of those. So you get x equals 4.9 and x equals negative 0.9. Okay. So anytime you're taking the square root of a variable, remember, if you're doing the square rooting in the equation itself, you've got to set it equal to both the positive and the negative. So that's how you find the second one in intercept form. Okay, I'm looking for other questions. Okay, so let's go. All right, so Paige has asked a couple questions about standard form. One of the things that Paige asked about is why equations look like this on one side instead of there being a y. For right now, I'm just going to tell you, don't worry about it. This is basically a notation replacement for y, and we're going to talk about it later in the year. You won't see it on your test at all. I'll have all y's there for right now, but we will talk about it later in the year. So we'll skip that one for right now. Really quick, Paige just kind of wants to go over standard form really quickly, so let's go ahead and do that. So we should get, I'm going to pick one that's hopefully not abysmally terrible. Let's see if I can manage to do that. This is a little tricky for me to do sometimes, but I think I can probably manage. We will try, yep, this should work fine. So we're going to try this. So actually, if you guys want to try to figure out the vertex, the x-intercepts, the y-intercepts, and make a quick graph, you totally can. I'll try not to speed through it. That way, if you kind of want to do that, you totally can. Or if you're watching this later on in the evening, you can obviously just pause and come back like we usually do. Okay. So remember, vertex for standard form is negative b over 2a, and then whatever you get when you plug it in. Okay. And the fact that I have to write plug in here is part of the reason for that F notation thing that we saw up here. It's called function notation, but again, we're not using it for right now. So negative b over 2a means we're going to do the x value of my vertex is going to be negative 2 over 2 times negative 1, which all simplifies to 1. So the positive one. So that's the x value of my vertex. And then anytime you have an x value and an equation, you can plug it in to find the y value. So I'm going to plug that in. And the key is order of operations here. Just make sure you're doing that really carefully. The negative does not go in parentheses with the negative 1, right? Because my x isn't negative 1. I'm squaring x, but my x isn't negative 1. Okay, so I'm going to square the 1, then make it negative. If I go through and do all of that math, it looks like I get positive 4. So I get my y value equals positive 4. So then I get 1, 4 is my vertex, and x equals 1 is my axis of symmetry. So then comes the question of how do you find x-intercepts or just generic other points or the y-intercept or all that good stuff. If you want to specifically find the x-intercepts, what you need to do is you need to change your y to 0. Okay, and then you have several options for solving. You can solve by completing the square. I'm hoping no one's going to choose that. Or you can solve with factoring or quadratic formula. I mean, both are probably pretty good. So it doesn't really matter in this particular case what you use, but in most cases, quadratic formula will be the one that works because it'll work even if you have irrational numbers, okay? So This one, you would just do like quadratic formula or something like that, or factoring, and I believe you are going to get x equals 3 and x equals 1. No, that's not right. -1. There we go. Nailed it. So you're going to get x-intercepts of 3 and -1. Now, one of the things, I don't remember if I talked about this with your classes or not. I know I talked about it with one class, but not the other. Good way to check whether your x-intercepts and vertex are right is the vertex in the middle of your x-intercepts? Well, if I got x-intercepts of 3 and -1, and I have an x value of 1 for my vertex, yeah, 1 is right in the middle of 3 and -1, so that's fantastic news. Okay. Now, once you do that, plus your y-intercept, plus using symmetry to figure out another one, you might be fine. But let's pretend you don't have x-intercepts or something like that, and you want to figure out some more points. All you have to do is plug in numbers for x. Okay, so if, I'm going to switch to a new piece of paper. For this particular equation of y equals -x squared plus 2x plus 3, as soon as I know that my vertex is 1, 4, the numbers that I would try plugging in for x would probably be 2 or 0. 2 or 0 would be the first two that I would look to plug in, because I want to try x values that are close to the vertex. Okay, so like in this one, it's not super necessary, but I would probably, let's just pretend for a second I plugged in 2 because I was like, oh, that's close to the vertex. I would just plug in x equals 2 and then figure out what y is. By doing that, and figuring out that y equals 3, I know that the point 2, 3 is a point on my graph because I plugged in 2 for x and it gave me 3 as a y value. Therefore, 2, 3 is a point on my graph. So really, in pretty much all of these cases, anytime you just want to find more points, you just keep plugging in numbers for x until you find enough points. Okay. So I think that answered most of the questions about standard form, hopefully. And Caroline, you asked a super specific question. I think I know which one you're talking about too. Don't worry about stuff that looks like that. So Caroline was asking about some crazy problem that looks like 1/2 y plus 4 equals x minus 7 squared. I don't think I looked over that practice close enough. So you guys won't see anything like that on your test. So really don't worry about it, okay? Really quick, the things that, and this will hopefully, because I know we're on about a 30-second delay or so, so I don't want to rush this too badly. But the things that you need to know test-wise would be, let's see, standard form, vertex form, intercept form, and then you need to know how to convert from standard to vertex. And in all three of those forms, not in the converting problems, but in all three of the standard, vertex, and intercept forms, you need to be able to figure out the vertex, the x-intercepts, the y-intercept, the axis of symmetry, and you need to be able to plot using at least 5 points. Now, in many cases, your 5 points are simply going to be the vertex, 2 x-intercepts, the y-intercept, and then 0.5 would be like whatever, like kind of the other side of the parabola was from the y-intercept, okay? So in a lot of cases, those will be your 5 points, but it doesn't hurt to know how to find others by plugging in x values. Gabby asked, can you give an example problem using intercept form? Sure. I think that was pretty much the one form we didn't go over anyway, so that'd be a great one to go over. Intercept form. Let me try one that's not too off the walls crazy. Let's go y equals -2 times x minus 1 times x plus 3. Excuse me. This is a pretty reasonable problem for intercept form. So again, if you want to write that down and try to kind of figure out some of this stuff, you may not be able to go through and graph the whole thing. And I'm not graphing right now either because they're pretty much going to look ridiculous. Like, unless we don't want me to spend time just making graphs here. Like, that's not a good use of our time. But if you need help with the actual graphing aspect, I'm hoping we don't, but if you do, come see me tomorrow. So this is a good example of something in intercept form. So for intercept form, the one thing that is definitively different, very, very different, is that you want to find the x-intercepts first. I'd say in most cases, you probably want to find the vertex first. But in this case, you want to find the x-intercepts first because they are by far and away the easiest thing to find. The x-intercepts are, if you plug in 0 for y, what you basically should hopefully realize is that since this is equal to 0 and it's all multiplication, you're just trying to figure out what x values would make each of those parentheses 0, which is just going to end up being the opposite of those numbers. So in this case, my x-intercepts are 1, 0, because that's the opposite of -1, and would make the first parentheses 0, and -3, 0. Okay? So that's what it would be. Now, once you find the x-intercepts, you are probably going to want to find the vertex next. What we have to remember is that the x value of the vertex is going to be right in the middle of those two x-intercepts. Should be exactly halfway in between. Okay? So there's lots of ways you can figure that out. The easiest way is by taking like an actual average. So you just add your x values of those intercepts up and divide by 2. In this case, we get -1. I mean, if you were totally unsure, you could honestly probably plot those two things on a graph and just start counting boxes in and figure out what ends up in the middle, and that'd be -1. So I know -1 is the x value of my vertex. And again, anytime you have an x value, you plug in the x value to figure out the y value. That is always true for any equation. Okay, so I'm going to plug that in for x. Okay, so that's kind of what it looks like when I plug in -1 for x, and then I just do math, and I get -2 times -2, which is 4, times 2, which is 8. So I get that I have a vertex of -1, 8. That would be my vertex, would be -1, 8. And then I should figure out y-intercept. Y-intercept ends up not being too terribly bad because you're just going to plug in 0 for x. And you'll get -2 times 0 minus 1 times 0 plus 3. That all ends up being +6. So I get that I have a y-intercept of 0, 6. And then all I would need to do is use axis of symmetry probably to find one more point. And hopefully if we made all that, it wouldn't look too terribly bad. I think that ends up looking about right. This one's gonna open upside down. So it's gonna have a vertex of -1, 8, and we're gonna kind of open down from there. Okay. So that's kind of the lowdown on what you have. Again, the biggest thing, this is what we need to know. Okay, you need to know how to graph if we're in all 3 of those formats. All right, and you need to know how to find vertex, x-intercepts, y-intercepts, axis of symmetry, and plot 5 total points in each of those versions. Again, the 5 total points will often be the vertex, the 2 x-intercepts, the y-intercept, and then just one other point that's probably straight across from the y-intercept. Okay, so We'll take a couple more questions. I'm going to basically, and again, I know you guys are on a little bit of a delay, but I'm going to give you probably about 2 minutes or so from now to get in any questions that you want. Okay, so get in any questions that you want, and then I'll answer all those, and then kind of once they're all answered, we'll just be all done. Okay. Right now, I'm only seeing one more that I have to answer. Okay, so the next one is Paige asked, "What if you have an equation in standard form?" That was something along the lines of y equals negative 2x squared plus 4x. Or really, I'm assuming what she means is pretty much anything with four terms. What you have to understand is that your c in this case is just 0. Okay, your c is 0. So you can kind of mentally add a plus 0, or you can physically add a plus 0. It makes it look a lot nicer. From a certain perspective, or more comfortable, I guess would probably be the right phrase there. So you would still do negative b over 2a. Everything like that would be the same. The biggest difference would probably come when you were finding x-intercepts. I'll do the vertex really quickly. What you have to understand is that because there's... Oh, sorry, I should hold this up while I'm talking. This is still... So negative 2 is still your a, 4 is your b, and 0 is your c. Okay, so when you do negative b over 2a, that's going to be negative 4 over 2 times negative 2. So my x value of my vertex would be 1, because that's negative 4 over negative 4. And then I'm going to plug that in to find my y value. And what's nice is that you don't have a plus something at the end to deal with there, and it's just a 1, so I'm going to get negative 2 plus 4, which is 2. Now, I am actually going to quickly think about this. My vertex is at 1, 2, which is above the x-axis. My a is negative, so it's opening down, which means this direction. It's starting up and going this way. That means I am going to have 2 x-intercepts, so I should find some x-intercepts. So I can plug in 0 for y. Now you've got kind of two choices when you get to there. You can solve with factoring, or you can solve with quadratic formula. I am guessing most of you will actually find it easier to use quadratic formula. Basically what you would do is your